Now I have the somewhat crazy task to say something at the end here, and I included into this a couple of fairly steep statements, so I hope we can maybe tone them down during the discussion afterwards. Okay, I have to switch this on as well. Let me just run through this here very quickly, because we have seen that this is essentially, I want to set a bit the model context. So this is Silo by Rolf Merkel. He has shown some of these pictures, so I think what we need to remember right now for the purposes of this talk is we model each synthetic person separately and then aggregate up later. Now this is MATSim. I started putting in some movies. Now I can't use my laser pointer because it doesn't show up on this screen, but I mean, obviously what you see here is that you have individual vehicles, and you have here a vehicle that's actually following a plan, going to work, stuck in congestion, all that. So there's a collaboration between several organizations. We represent everything we need individually, so we have individual traffic signals and individual intersections and stuff like that. We iterate, kind of similar to regular assignment, into something that Kai Axhausen, I think, correctly calls a schedule equilibrium. So it includes mode choices, not just route, but also mode and departure time, and sometimes especially secondary activity location choice. So where do you go shopping? Where do you go drink a beer? Includes several modes, most importantly also walk, bike, taxi, cab, autonomous vehicle. It has a fair number of analysis modules. And one thing I want to mention is, because it's following this full daily plan, the schedules are automatically consistent. Yeah, so you can't depart before you arrive, because just hard-coded into the way it approaches the problem. Now, one thing is, I think, despite all the problems we have, we need to learn how to use other teams' models, because doing everything by ourselves is, I think, not the long-run solution. Now, I don't know what this means for consultants. They might have a slightly different problem, but I think for academics, I mean, given that we usually have groups with 5 to 10 people, we can't just re-implement all the good ideas that somebody else has. Yeah, somebody has a fast routing algorithm. I can't re-implement. Eventually, I need to be able to pick it up. So I somehow think we need to do this. Now, one thing that we have with these models is the traditional coupling. We had this a couple of times. Is we probably have the land use model. We generate an OD matrix. We give it to the travel model. This is not always, but that's one possibility. And then the other way from the travel model, and I keep this calling T model and LU model. We usually have the skims, which is zone-to-zone travel time, so you give this back to the land use model. Now, the question is, why does this work okay? And I think there are two reasons why this works okay. And one is, these are stable interfaces. Yeah, they have been used for 20 years, so we know how they work. And so we have a tendency to use them again, because they're kind of established and all the softwares offer them. And then another reason, I think the way most of the work is done, the travel model is interpreted as a stable library. So if you're doing the land use model, you're programming happily along, but you kind of assume that the travel model is something where you buy an ML license and then you keep the same version running for 3 years. Yeah? You essentially never change that. And I don't think it's the way in the future. And these slides are now a bit thinner than they were originally, because I wanted to save some time. But I think what we need to do is we need to move on to person-centric coupling. And one reason is actually something like this, is if you think from the perspective of a residential choice model, and maybe I'm getting this wrong because I'm on the travel model side, but I mean, if I would do a model like that and I would say, I have a job offer from somewhere and I want to look for a residence, I would look at all my different options here. And this I actually stole from Dominic, who is doing much of this work actually that I'm showing here. Yeah, so you would want to say, here are my different home options, and for these different home options, I have different travel times to my final job. And so based on these very microscopic ideas, I want to have an idea what I select. Maybe I want this by walking and by bicycle and by public transit, and maybe I want to know this for 7 in the morning or 8 in the morning, and maybe I want to know this for an electric vehicle without toll versus a carbon vehicle, including toll. So there's lots of these fine-grained decision things that I need, and I mean, small details matter, because if I'm directly next to a transit hub is different from being a kilometer away. Yeah? And so there are relatively small detailed questions that matter, and if we do everything at a highly aggregated zone level, that somehow doesn't work. Now, if you think about this a little bit, what you now need to pass from the land use model to the transport model, I think, is still relatively clear. You essentially pass the facilities. Yeah, so rather than then passing the zones. You say here's a supermarket, and here's an office building. And this kind of is relatively clear what you do. And I think the other thing that you pass is rather than zonal average, you just pass persons. You say here's a synthetic person in here and here and here. And I think we talked about this yesterday, and this is kind of why I put it up. I think we should just change the fundamental objects that we pass. And maybe make this switchable, but at least an option. Now for going back, it's a bit more tricky, and I think in the end, what we find is that we probably, and I don't know completely, I'm not completely sure, but it looks a bit like we're not passing preemptively constructed objects back. Yeah, so in the past, it was these zone-to-zone impedances. They were pre-computed on the travel model side, the skims, and they were sent back. And then the land use model does whatever it does. Actually, Paul Waddell with UrbanSim, I think he's now passing the network back. Yeah, so he's passing the network, and the link-based travel times is passing that back. I kind of say what maybe might more sense is that we invent some kind of query architecture. Yeah, and we all know this. Yeah, we query Google for the fastest path from A to B, and you get an answer how to do this by public transit, by what, and you can vary the departure time. And so kind of an interface like that. And I put this up here because I think this might be part of the question. What is going to be the stable interface in 10 years from now? Because we need some stability. Now, in the meantime, as long as this is not stable, we need joint development. Yeah, so this idea of saying the travel model is the stable thing and I program the land use model around this doesn't work. So we need a setup how to actually do software development in parallel, given that we're probably in different teams. And I want to say a couple of technical things for these things because I think there was actually pretty good progress essentially over the last 10 years, but it kind of has really accelerated over the last year. And I just want to show what's possible now and what you can do under certain circumstances. And this is at least our way into the future. Now, there's GitHub. Many of you know that as I actually stumbled during this conference across this here. So Parsons Brinckerhoff has obviously also found this, and they have this model there, so people are using it. If you go to MATSim, kind of the same thing. Now this is a subview, and what I now want to point at here is, if you go to this here, you see the same as we just saw before. And this is the different branches, and this is not really my main point. My main point is that it's integrated with GitHub, and you get this for free. This is essentially half a day of work, and then it actually starts doing is you get automatic regression testing. So I can click on this button here, and then what I get is a view like this, which tells me that my MATSim tests have actually worked, and there's different views on this, and one of this is here, where what you actually find is there's all these different branches, and they are red and yellow and green. This is red is like non-compiling, yellow is compiling but not passing regression tests, and green is everything is passing. You have a history and all that. Yeah, so you get automatic regression testing, finding out if your software is still doing what it did a day ago. And I think everybody who's doing software development on the professional level knows we urgently know this. Now, this is now a commodity thing. Yeah? The important thing here is now that this is no longer just big companies. So this comes if you have your project on GitHub. This is a couple of clicks to implement it, and then you can actually start using this. So this now, every PhD student, every master student can actually start using this kind of facility. Now, the next thing that just came out over the last year or something is GitHub supports automatic deployment. Now, deployment essentially means once your software has passed the regression tests, it is made available to outside users. Now, this is also a commodity thing. You just need to put a couple of strings into your software, and then it actually makes yourself available to others. Now, the way this looks now from a user perspective is something like this here, and this is why one reason why I wanted my own laptop. So we could have something like this here. Now, this is Java, where we say, I call Zilo MATSim, and then I run it, and I put in a MATSim config, and now somebody says, I want to add emissions to that. Yeah, so I want to have an output where I actually get, and I will show you a movie how this looks a little later, where I just want NOx emissions over my whole system by hour or something. And so what you essentially can do now, you can go in here, you say add a dependency, you type in emissions. This is now essentially a worldwide search, so nobody else is doing emissions right now. You open this, you add your version. Then it does blah, blah, blah. Now, the blue thing is actually, this is now pulling it from the internet. Yeah, so there's nothing local anymore. This is just pulling it from the internet, is pulling the version I clicked on. If it says a snapshot version, it says it pulls the newest version. So if I do it tomorrow again, I get a newer version. So this is how you can actually collaborate with these things. And now I can actually do here, I can say I start using this. So in this case, in MATSim, you just put it into the config. This is this Java thing that you need to import this. Yeah, so it's there now. And now I have this configuration. I can do something like emissions. I have cold fingers here. Dot. And then this is kind of all the stuff I can configure. And we're still fighting with this a little bit, but those who have actually used Java, you know if you do it this kind of way, then you can actually click through the Java docs. So here right now it doesn't say a lot, but we can start adding this config option will configure this and this and this, and you can use it, yeah? So all this game that we need to go somewhere, get an executable, implement it locally in our machine, fight with the fact that something works on Linux and the other one works on, is all gone away, yeah? This is all essentially just there, and you can start working your way forward. So in terms of this slide here, this is essentially the way it looks. You say, where should it come from? What is the module I want? What is the version I want? This is actually very useful because you can say, doesn't work, I go back to what it was last year or something. I can say, I want to deliver this to a customer, so I put in a stable version that doesn't change anymore. Or you can say snapshot. Snapshot means I get the newest version, so if Rolf changed something on his side and I changed something on my side, then a day later they will all come together and work again. So the version comes from the cloud, and if whatever you pull down depends on other libraries, these are pulled down automatically as well. So this is hierarchical. It doesn't have this, that you don't have to install 5,000 libraries, but if there's additional libraries, it's just pulled in by itself, and then it works. Now, one thing is what you need for this right now, I think you need Java. I don't think it works outside that language. So this is a big advantage right now. Maybe other languages have the same, I don't know. I mean, Python has it a bit similar, I know that. But at least for Java, it works very well. And the way it looks in the end now is that you do everything in code. Yeah, so you can say, the MATSim side could say, give me all the persons from the silo side, or give me all the zone properties if I want to know if I can go shopping somewhere. And then from the Zelo side, you could say, get me the accessibility of a location. Yeah, so if you're looking for, as an investor investing at a certain location, you say, give me the accessibility, or you could say here, get properties of transit connection, where you say, I'm considering a location here, and this is where I work. I want to know how long it takes and how expensive it is and what the reliability is. Yeah, so it starts being these things. It's no longer that you have these huge matrices and you need to decide which of these elements is what you need, but you ask these queries. It's one executable. That was kind of the argument Michael Wegener made. So this is not a number of executables that are bound together by a script. This is one executable from the user perspective. And so I think this argument then also is kind of preempted by this approach. Okay. Now, about programming languages. This is now a bit of a steep statement, but I want to make it anyway. I think different programming languages is the most important impediment to model integration. I mean, we have wasted, and this is why it's in red, we have wasted enormous amounts of time trying to couple UrbanSim and MATSim. And I think we're probably going to do it again with Eric Millers because we're interested in that. And hopefully, eventually, a better technology comes up, which is kind of this thing here. But right now, and this is part of, I think, what we have here, is if I'm doing a land use model, I'm doing it in C#, kind of putting MATSim underneath is also a bit of a waste of time. So there should be a C# model to put underneath, and then hopefully, eventually, for the timing, this is the way it is. Java works with Java, C# works with C#, C++ works with C++, and Python depends a little bit what's underneath, but it's usually C++, so Python works with Python and with C++, and that's roughly it. So, and Harut had this a bit more balanced with tight coupling and loose coupling and language conditions, so this is now a bit more the steep version, but I hope you get what I'm getting at now. This is MATSim for UrbanSim comparison. I said skip, but I think I have enough time to talk about this. Was EU project, about 10 partners, 2010 until 14. Kai Axhausen was the scientific one of the two coordinators. And if you go through the points that I just made, dependency management on the UrbanSim side existed only for Windows, which meant installing it took about a week on a non-Windows machine, UrbanSim. Deployment, we had nothing at the time, so we had to manually pull down from software repositories. Regression tests we already had, and same language we didn't, which in particular means we couldn't do person-centric queries, and this is in the end my point right now. with the way this is set up, I think without person-centric queries, I don't think we can move into the future. Yeah? So I think we can still do the OD matrix-based and the scheme-based coupling. That's fine, we can do that, but I think the way into the future has to be more microscopic. In order to be more microscopic, we somehow need to get to this down, and right now I think this only works inside the same language. Okay, so overall, to summarize to this point, if you stay in this Java Maven GitHub world, and actually, I mean, best you are open source, because then you don't have to pay for these things, and as long as we're academics, I think we can actually be open source. You get the build server for regression tests provided for free. This is actually quite a feat, I mean, because there's a fair amount of computing time that just comes up for free. Deployment is provided automatically, and external library management, including versioning, is also essentially for free. Get a single executable. And finally, if you are going that path, it's actually easy to replace the traffic model. Yeah, so if you have done that and you have run it with MATSim, say, it's also slow or too stochastic or whatever, somebody else can implement an alternative. Maybe Kai Axhausen by then has something that has the same interface. I mean, you can still, if you go back, I mean, even if I don't have a schedule-based thing, I can still answer this. I mean, I can still say, based on my network fundamental diagram, the property of this is that it takes so long and has this price and whatever, and then you put in your measure and you change the fundamental diagram, you can still answer these queries. Yeah, they don't need to be answered microscopically behind the interface, but I think it makes sense to set the interface up in that microscopic way. Yeah, so this whole approach, and you just saw how I added the emissions, so kind of replacing the travel model under the same interface is just going to this Maven deployment file, replace one model by the other, and off you go. Yeah, so this is what I think we should do. Now comes the advertisement section. If you take an already existing model done by somebody else, you get a fair number of capabilities, and I collected some of them here. So this is NOx over time of day in Munich. If you add this emissions module, this is noise, which I think we saw this already very similar. Noise over time, there's actually time over here. It's hourly, so you get this kind of computation noise. So essentially it's putting up synthetic noise measurement devices and looking what kind of noise arrives. Now this is maybe not fine enough for many fine-grained policy decisions, but at least it's there in an integrated way. You don't need to plug all of these things together. And maybe in the long run, we get another plugin that does this in a better way, but here it is so far. Accessibility, this is a study Dominic is doing. This is somewhere in South Africa, Nelson Mandela Bay. And in particular, it's looking at townships. So here's a township, and this is accessibility to workplaces, and red means not good. So and there's also, here is also a township. So there are certain townships where accessibility to workplaces is actually okay, and others where it's pretty shitty. So you cannot say townships need to be improved, but you actually have to look at them one by one. Autonomous vehicles in Berlin. There's this thing in MATSim, if persons have plans, and the plan is activity lag, so it's an activity-based plan, like everybody has in their mind. Between, there is no choice, and so you can just replace car by autonomous vehicle. And there's software that does that. So it will say 10% of people now replace car by autonomous vehicle and try it out. So MATSim is kind of a trial and error simulation, so essentially it's just given to the simulation. And it's given there, and like if this person here then waits 2 hours for the autonomous vehicle to arrive, next iteration will say, okay, this wasn't such a good idea, and not do it again. Which also means that all the physics is automatically there. And this is a simulation of this for Berlin. So this is all of Berlin, like 3.5 million people. All the vehicles inside the urban limits, which is the red and the green ones are replaced by autonomous vehicles, and the blue ones are coming in from the outskirts. Those are the ones we left in place. And then you have this stuff like here is a vehicle, and red means it has a passenger on board, and then it will eventually start moving forward. Yeah. And deliver the passenger, and then it's just green and going to some place, picking up a passenger. So right now the vehicle's gone, and now it's red again, and it's delivering it. So it's a completely mechanical model, and if you say, I want to look at waiting times, you can like increase or decrease the fleet size. There's a dispatch algorithm behind that, yeah, which AV vehicle is going to which customer, which you can change. You can look at congestion effects, because pretty clearly AVs have empty trips between the full ones, so they are doing more vehicle kilometers than before. And if you want to do mode choice, as I just said, you can also have like public transit passengers move over to AV and see if they're more or less happy. And you can look at different pricing systems, and if you have a reasonable mode choice model, this all comes count. Now, I'm not saying that we have all the behavior sorted out, but at least the hooks are there, and it's pretty clear how you do this. And this is like how an AV runs over the day. Bicycles. So this is actually from Patna in India, where bicycles are pretty important. So you see here that we can actually have bicycles, and we can have like cars drive through them. So we also have a facility where essentially you can just bicycles and walk, and you can just assign this on the network. In this case, the bicycles are congested, which means if there are too many, you get queuing, which in India is quite important. And so this is also, you can, essentially the way it works is you have the network underneath. You can add links that are restricted to cars only or bicycles only or everything or buses or whatever. And then the simulation just routes and executes on that modal subnetwork. It's pretty straightforward to do. And if you go from OpenStreetMap, you essentially just put it into your converter and add that. There is something that generates social networks. We mentioned this yesterday. There's a website actually in MATSim that is extensions, and there's a long list, and 2 of them do that. I want to show this. There's a visualizer here, where essentially this is the visualizer, and you can actually pull just stuff over. So you put the network over there, you put the, see, it shows up, and then you put the events over there, and then you load this stuff, which takes a little bit. I just want to show, because sometimes people have the intuition that this is extremely hard to use. I would say this is actually not very hard to use. And then here you go, and you have actually traffic in the Tampa Bay area in the way you would actually want this, and you can actually look at it and start analyzing it and all that. And this is this thing about making results available. We're struggling with that. This is why I asked one or the other question. This is one thing we're trying right now, where we're actually putting this on a geo server, which is kind of an infrastructure, and you can do this kind of thing here, which is maybe not the best way to do this, but we start making products available. There's actually, I'm not showing this, but from a ArcGIS or QGIS, you can actually zoom on your area of interest, and then you don't get the full list, but you only get the list of those products which are spatially relevant to the area you're looking at. Yeah, so it works that way. I don't have enough time for that, but you can click on this here, KML, which I'm not doing because I have prepared it here and I want to save a little bit of time, but essentially then you get it into Google Earth, which means you can now make it available to everybody. Yeah, you don't need an expert for this anymore. And then here you can obviously, you can do this, you can kind of zoom in here. And I mean, this cloud-based has a bit of problems, but you can kind of look at certain types of accessibilities, look at your own location, look at where you want to go, give this to planners, all there. And this is not, maybe not yet the best way to do it. As I said, we're struggling with that a little bit. And one final thing, because we kept talking about sliders, but never had them. This is one that is based on MATSim, and it's not terribly interesting. It just says that we can do this. This is kind of looking at Tegel Airport in Berlin, and then kind of the number of people who are within 15 minutes difference, travel time essentially by autonomous vehicle. So a little bit, this was driven by, they have a 4-hour door-to-door challenge in the European Union, and so kind of trying to figure out how many people you can actually transport from A to B within 4 hours. This is kind of where reachability of airport is important. This is one of these things, if you start doing this with train systems, it's game over. Yeah, so if you want to get people in 4 hours from one place to another place with an airplane connection in between, we need to do something like AVs, otherwise it just will not happen. Maybe it's not a good goal, yeah, that I don't know, not very sustainable, but there are certain things that just don't function with these things. Okay, so before I finish, because I'm the last speaker, Rolf, thank you very much for organizing this. This was an excellent workshop. I think we all agree with that, so maybe this is the time where we clap our hands. Enjoyed it a lot, learned it a lot. Was a nice environment. We had nice food. Was very interesting to listen to everybody and talk to everybody. Thank you very much. And on that, I have a quick summary, which essentially just tries to make these 2 points. One is, if you stay within this Java tool chain, there are no very helpful deployment mechanisms that we can and I think should use. And the other thing is that in the end, we somehow need to start to combine, because that's the only way we can put these extra things in there that you will never get if you kind of re-implement a travel model or something like that. Thanks.
This was a firework of interesting stuff. So pass the microphone right. Alistair?
Thank you. Thanks. Very inspiring, I would say, talk at the end. And I agree entirely with the need to think more carefully about our software development. We've dabbled with Github, and my PhD students use it, but we've never really used it as a kind of serious deployment tool to give it to the outside world. We just use it in our team to make sure we know what's going on. But I agree that, you know, by doing this kind of approach, you know, we can at least see what each other's models are doing and which version we're up to, and it makes things much more understandable. There are efforts to develop tools to link Python to Java directly at the kind of native level. So the kind of things that Harut presented yesterday with using ArcGIS with Python model runs, there is the potential there that you could use an ArcGIS front end if you wanted to bring in data from elsewhere, from web map servers or web feature servers into an ArcGIS front end, and then maybe call in even MATSim functions from that kind of environment. So these possibilities are there. I think we just need to kind of get our heads around them maybe and explore them a bit more. Because we work in a Python environment out of choice, and probably because we started from a GIS environment, that was the obvious thing to do. But other people, yeah, Java's obviously got lots of advantages too. So if we can start joining these different environments together as well, then we've got even more power at our fingertips, I think.
Yeah, not much to add except that Python-Java bridge, I'm not sure how quick that will be to materialize. So I wouldn't bank a project on that.
Thank you, Kai. Very interesting presentation. I'm quite impressed about the capabilities of MATSim. I'm curious about NOx calculations. Do you have a different type of cars, like different engine size in MATSim, like how it is implemented?
Yeah, I mean, I'm not sure how much the Volkswagen stuff is included in these things, but the way it technically works, there's a vehicle database which is essentially based on HBFA, handbook for emission factors in I don't know, in Europe or something. So there is a lookup table for these things, and it takes the car types from that. So that's one side. Now the other side would be the model side, and that depends a little bit if you actually have on an agent per agent basis actually the different vehicle types. I mean, so far we usually do like average carbon vehicle and average electric vehicle, and then put like a Volkswagen Golf behind that and an electric vehicle, and then we put in the emissions characteristics from that. Now the emissions characteristics in HBFA, I think they have 4 traffic conditions, so they have like free flow and congested and stop and go and essentially stopped. And so we take this from the simulation, and then so we have the traffic state from the simulation, we have the vehicle type because it's a microscopic thing, then we go to the lookup and we do this on a link per link basis, including keeping track of engine temperature. And so we do per vehicle, per link, the emissions and then add them up into what we show there.
I'm curious about the cycling simulation. So I can see how you would simulate independent cycle lanes. So cycle journeys that are independent of vehicles. In the UK, at least, then most of our cycling is conducted in a shared way. So you're cycling on a road and you're sharing the road with cars. Now there are some car drivers that don't care at all about cyclists, and they're not going to alter their trajectory. But there are occasions when car drivers are quite respectful, and they'll wait until they have a moment when they can give you a wide berth, and that, of course, is a function of the oncoming traffic. So I'm just kind of wondering how you handle that.
Yeah, I can't explain this in 2 sentences. This is a fairly aggregated model which generates fundamental diagrams, and we haven't found any good investigations of this in reality, so we decided this is what it is. Essentially what it does is cars can pass bicycles as long as they are still in the free flow regime, and as soon as it's queued, they can't. Yeah, and then it's a little bit computationally driven because the data structures for this were easy to implement. And then we looked at the fundamental diagrams and we compared to whatever we find in terms of measurements, and it doesn't seem to be very far off. So we need more transport engineering there before we can make progress. Yeah, so they interact, because for India you actually need that, because the bicycles are caught in congestions. Also, if the intersection is full of bicycles, the cars can't pass anymore, so it was driven by that. So if it's very full, they're caught in the same congestion.
Kai, you made a very strong point for reusing models and sharing models. One point that we briefly discussed in the break is that there's also a benefit in developing something from scratch, because you build on new ideas, you develop something new. And I just was thinking, this is probably the first event where I present Silo and I'm not challenged, why didn't you use UrbanSim, right? But there are reasons why I did not use UrbanSim, but I want to do something different. When do you draw the line that it's better to reuse something, or it's better to start from scratch and do something different?
I would probably do both. I would probably implement a very simple traffic simulation myself underneath the same API, and then use a more complicated and complete one from elsewhere, and I would probably switch back and forth and see if I find semi-consistent output. I mean, here we can't do this yet because we still need the API, yeah? So Silo MATSim, I think we have to live with that for the time being. But once it's a stable API, and if I then would be the next PhD students in 5 years from now and somebody says to me, you have to use MATSim, I would say, okay, let's think about a simple, I mean, if my results strongly depend on that, I would put a very simple thing underneath and then, or maybe even keep inside the group and then replace.
To follow up on that, which I think is consistent with what Kai has been talking about here, I think one of the problems is traditionally, regardless of the language it's in, what I would call model systems like UrbanSim are very monolithic, and not modular, so it's not easy to necessarily bring your new ideas to existing software because the software hasn't been designed in an extensible enough modular way. Now I know UrbanSim's in Opus, so maybe this is not the best example, but I think that one of the reasons we keep developing our own models is because we can't, and part of it's a language thing, but also it's just structure and different things that don't allow us to swap things in out. You have a better residential location model. You can't just swap it into UrbanSim and for all sorts of reasons and test it. And I'll probably say a bit more about this later, but I think getting to a more modularized view of our model systems so that you can be testing things in a common environment would, maybe we get to a point where when you want to test new ideas, you don't have to start from scratch anymore with your own model system.
Okay. Kai, thanks a lot.
Sure.